Hello everyone, myself Thuma Kaushik, me and my project partner Priyansh Jain have successfully completed our minor project named Weight-Based Sorting Machine under the supervision of Dr. D.K. Kothai sir. In the next slides, we are going to present our minor project. Presentation started with introduction, then discussed the three different design approach, and after that, circuit diagram and block diagram of final design approach are included. At the last of presentation, the future scope and conclusion are added. After industrial revolution, majority of tasks are performed by machine itself, in that certain machines has some intelligence within it. In that process, the conventional method consume more amount of time, and as a result, the process becomes slower. The solution of this problem is to build an automatic sorting machine that can able to sort objects according to their weight, color, shape, etc. and work fast and effectively. Sorting machine is a more economical method for sorting objects as well as transport them from one point to another point. Here, we have proposed the one basic implementation of sorting machine that can able to sort objects according to their weight. To make system faster and avoid human interaction, the conveyor belt is used to transform object from one point to another point. Here, first design layout is displayed in the figure 1. In that, the conveyor belt is placed at the angle of 90° and 270° with the main conveyor belt, and the weighing machine rotating platform is placed between them. In that approach, the major problem is to rotate the weighing machine platform. So when we rotate the weighing machine platform, the corner of the weighing machine platform are touched with conveyor belt, and it will create a problem. So we move towards the second approach. In the second design approach, the conveyor belt are placed at a 180° to the main conveyor belt, and the weighing machine platform is placed at a certain height with reference to conveyor belt. So by rotating weighing machine platform, we create a slope so that the object in the weighing machine platform will slide to the conveyor belt by the gravitational force, and it will move forward with the conveyor belt. The third design approach is a modified version of the second design approach for better space and power requirement. It is a final design approach. In that, the conveyor belt are placed at a 360 angle to the main conveyor belt, and some LEDs and IR sensor are used in this design. The working of LEDs and IR sensor are explained in the further slides.
Various elements are shown in the block diagram work as follows. Arduino Mega is processing and control unit, IR sensor to detect the incoming box on the main conveyor, load cell to measure the weight of the load box, HX711 to receive and amplify the voltage variations of load cell, convert variations to 24-bit digital value and send the data to the Arduino board. 16 cross to LCD to display various things, Johnson motor for running the conveyor belt, servo motor to rotate the weighing platform, relay to stop the main conveyor whenever required, op-amp to remove the erroneous output of the IR sensor. The shown figure represents the circuit diagram of the software simulation as well as The hardware implementation. The flowchart tries to explain the various tasks performed during each sorting of the weights. After switching on the weight-based sorting machine, various tasks are: first, tare and calibration process is completed. After that, the machine waits for any weight to come onto the weighing platform. When some weight is already present on the weighing platform, and if another weight is detected on the main conveyor by IR sensor, then the motor of the main conveyor is turned off by sending the signal to the relay. If the recorded weight on the weighing platform is less than 20 grams, then the weighing platform remains horizontal, both the LED remain off, and no load condition is displayed on the 16 cross 2 LCD. If the recorded weight on the weighing platform is between 20 to 300 grams, then the weighing platform tilts towards the right hand side. The LED of the right hand side turns on, and the right direction arrow and incremented count is displayed on the 16 cross 2 LCD. If the recorded weight on the weighing platform is between 300 to 1000 grams, then the weighing platform tilts towards the left hand side. The LED of the left hand side turns on, and the left hand direction arrow and incremented left count is displayed on the 16 cross 2 LCD. If the recorded weight on the weighing platform is above 1000 grams, then the weighing platform remains horizontal, both the LEDs turns on, and the all-out condition is displayed on the 16 cross 2 LCD. The selection of the suitable motor to run the conveyor belt, with taking some errors and hardware changes in consideration, was a difficult task, and the shown calculation helped us to some extent to do so. There was a poor current distribution between the different components of the hardware circuitry. Due to that, some problems like automatic hardware reset, garbage content display on 16 cross 2 LCD, improper working of servo motor were occurring. In our case, these issues got solved by providing power through more than one 5-volt power supplies with common ground between all the 5-volt power supplies and different ground between 5-volt and 12-volt supplies. The another challenge was the erroneous output of the IR sensor. Ideally, the output of the IR sensor should be 5 volt for logic 1 and 0 volt for logic 0. But actually, it was generating 2.1 volt for logic 1 and 0 volt for logic 0. In digital circuits, mostly the voltage of 2.1 volt is considered as logic 0. This issue got solved by passing the output of IR sensor through an amplifier circuit. This is how the hardware of our minor project looks like.
Here, those pictures are circuit design that we have created for our project.
Now let's see the software simulation of the project. Here we have used Arduino Mega 2560 uh, as controller, IR sensor for detection of incoming weight on the main conveyor, load cell to measure weight in terms of voltage variations, HX711 to calculate weight based on voltage variations, virtual terminal as serial monitor in Arduino, servo motor to rotate the weighing platform, 16 cross 2 LCD display for display purpose, LEDs D1 and D2 to show direction of sorted weight, Johnson motor with relay to control the rotation of main conveyor belt. Here we need to include the hex file of IR sensor as well as the Arduino board. The hex file of Arduino board can be generated via compiling the Arduino code which we have written. Now let's simulate. After completion of startup, it will ask to enter T to start the tear process. But before that, we need to make sure that the load cell should be at zero point 0.0 to measure the 0 gram weight. After the completion of tear process, it will ask to place some load to measure the initial value. So make load cell at 1.0 and enter value 100 grams. After completion of calibration process, it will ask to confirm the value of 100 grams. So press Y to confirm. After confirmation, it will show the current value of placed load on the load cell or weighing platform. Since the current since the current value of placed load is 100 grams, so the right side LED is turned on, and right side count is incremented by 1, and the weighing platform is rotated towards the right side. Now let's increase the weight on the load cell to 300 grams. As the measured weight becomes 300 grams or more than 300 grams, then the left side LED will glow, and the left count will increment by 1, and the servo motor or the weighing platform will rotate towards the left side. Now let's place a load greater than 1 kg. Here 11 meaning 1100 grams. So at 1100 grams, since it is greater than 1 kg, it is showing overload condition, and both the LEDs D1 and D2 are turned on, and the weighing platform remains horizontal at since servo motor remains at 90 degree, and no, since on the weighing platform there is some load already present, which is overload, and if some load or some weight is detected on the conveyor belt, then no, then the Johnson motor will turn off, and it will stop the main conveyor belt. Now let's decrease the weight no, to 0 grams. As the measured weight becomes 0 grams, then no load condition will be displayed, and both the LEDs are turned off, and there is no effect of IR sensor detection of weight through IR sensor on the working of Johnson motor, and in this condition the weighing platform will remain horizontal.
This is our hardware design for a minor project titled as weight-based sorting machine. First, we remove the load in the weighing machine platform, then enter the T. T is for tethering that ensures that no weight is present in the weighing machine platform. Then we can place the well-known weight load in the weighing machine platform to calibrate the weight of the weighing machine platform. Here we have placed a soap that have weight 135 gram, and after that we press simply OK to confirm our weight. Then according to the weight the object is short. Here the weight of the soap is 135 grams, so it will go towards that direction as the weight is less than 300 grams, and it will show that one object is sorted in the right direction, and the arrow is the displayed the direction of sorting. As the loader is go to conveyor belt, no load is present in the weighing machine platform, so it will show no load. As the load is go to go into the weighing machine platform, it will measure the weight. Here the weight is 200 grams and it will less than 300 grams, so it will go towards the right conveyor belt and the show number 2. The third weight is 290 grams, so it will also go into right direction and the display the number 3. 3 is the count that objects are sorted in the right direction. As long as the weight are go in the weighing machine platform, the main conveyor belt are stopped because of the power saving mode. Like if two objects are nearby, then we cannot allow two objects at a time in a weighing machine platform. Here the object weight is greater than 300 grams, so it will go towards left direction and it will display the 1. Similar for the object has weight 210 grams. This object weighs more than 300 gram. It will display the 417 gram, so it will goes towards the left direction, and the count number 2 display that second object are gone in the left direction. As you see, whenever the weighing machine platform rotates, the LED will blink. It will show the LED is both side in the main conveyor belt. So if the weight goes towards the left direction, then left LED will blink. And if the weight goes towards right direction, the right LED will blink. Here we have put a condition that if load is greater than 1 kg, then it will show overweight. So as we discussed, it will display overload. And in that condition, both LED will blink at a similar time. And if the weight is less than 20 gram, then because of the limitation of our structure, it will not display anything. In this project, sorting of objects is done based on their weight component only. But in real life, weight is not sufficient for sorting objects alone. Sometimes the shape of object and color of the object are also important, like in case of sorting fruits. Sometimes X-ray vision is also required for sorting objects. So, according to application, our project is clubbed up with the key factors and provide appropriate results. More add on to it, the data can be transmitted into the IoT cloud, mobile application, or remote server with the IoT configuration to store real-time data and to monitor it. To add to it, it is possible to implement it with necessary condition to be implemented. At last, we conclude that our design is effective in terms of space and power requirement. It was able to differentiate load using threshold value. If user wants to change threshold value, it is possible. The IR sensor is used for time management. Also, the speed of motor that rotates conveyor belt may be changed by using the motor speed controller and the Arduino. Here we have not used that because we don't have need that.